Hello friends, this is one more video on connected motion and free body diagrams. So I have chosen a numerical rather to once again explain to you how to handle questions on free body diagrams. So this is the question: two blocks of masses 10 gram and 30 gram are fastened to the ends of a cord which passes over a frictionless pulley. So we have a frictionless pulley over here, and these are the two weights, 10 gram and gram fastened over here, and the 10 gram block rests on a table. This 10 gram is resting on this table. The question is, what minimum force must be applied on the 10 gram block to keep it on the table? So what force should I apply on this, right, in the downward direction so that it remains in contact with the table? And the second question we have to answer is, what will be the tension in the cord under this condition? So when I apply force onto this to keep it in contact with the table, what will be the tension in this cord, right? Okay. If you look at this diagram closely, right, this is 30 G acting in the downward direction, right, and 10 gram has a tendency to go up because 30 gram is larger, so this will have a tendency to go up, this will have a tendency to go down, right? So if I look at if I talk in terms of force, right, the force acting downward direction is 30 GF, right, and here the force acting in the upward direction is 10 GF, right? So if I want to keep this down in contact with this table, I will have to apply a force, a downward force in the downward direction of 20 GF, because 30 GF is trying to pull this up in the upward direction, whereas the weight of this is 10 GF, which is trying to take it in the downward direction. 10 GF is acting in the downward direction, right? And so I should add another 20 GF to this, so that this becomes the net force on this becomes 30 GF, and it overcomes this force which is trying to take it up. I hope that is clear. So the net force, the answer to the first question is that I should apply a force of 20 GF, right? And if I want to convert this into Newton, what I know that 1 GF is equal to 1 upon 100 Newton, where G is, if we take G is 10 meter per second square. So this will give me is equal to 0.2 Newton. If I had taken G as 9.8 meter per second square, then this force would have turned out to be 0.196 Newton, right? So the answer I'm getting is 0.2 Newton, right? Second question, what will be the tension in the cord under this condition? So what will be the tension in this condition? Again, a very simple approach. The force acting on this, now if I look at this rod in continuity, if I look at this as one complete rod, then the force acting on this end is 30 GF, because 20 GF is the weight of this block and 20 GF is the external force being applied to keep it in contact with the table. So net force here is 30 GF. The net force acting over here is 30 GF. So if I show this as one complete body and as one rod, then I have a situation like this, that here 30 GF is being applied, here also 30 GF is being applied. 30 GF is being applied, right? Therefore the tension in the rod will be 30 GF, right? 30 GF, and that will be equal to 0.3 Newton, right? So 0.3 Newton. So that would be the tension in the string. Tension, it would be 0.3 Newton in the string. Okay. Let us, for the sake of our discussion, assume that we remove this particular force of 20 GF, right? If we remove this force, then what will happen is that this block will start going up. So let us try to find out the acceleration. What will happen is this will start accelerating upward in this direction. 30 gram weight will start accelerating in the downward direction, right? Tension in the string will be T here, tension will be T, right? So now let us look at this and entire situation and look at free body diagram for 10 GF. So let me show 10 GF over here, right? This is a 10 GF, right? So 10 GF is acting in the downward direction. In the upward direction I have tension, right? And this is moving with acceleration A. So I'll get the equation T minus 10 GF. T minus 10 GF is equal to M is equal to 10 into acceleration. Of course I should get the unit, right? So I will divide this by 100 and this also by 100, so I get the unit in Newton. So T minus 10 upon 100 is equal to 10 into 100 upon, right? So this is equation 1 I get, right? So this will be minus 0.1 is equal to 0.1a. Let me call this as equation 1 instead of calling this. Okay, if I look at this particular block now, we can do it this directly. The downward force would be 30 GF, right? 30 GF. So 30 upon 100 Newton to be more precise. 30 upon 100 Newton is the force, and T is acting in the upward direction. So 30 upon 100 is trying to take it down. T is in the upward direction. Acceleration is in the downward direction. So for the second block, I'll get 30 upon 100 minus T is equal to 30 upon 100 into acceleration, right? So this is what I will get. 30 upon 100 is, so this will be 0.3 minus T is equal to 0.3 A, right? This is equation 2, right? And if solve this equation, I'll get 0.1 plus 0.1 A is equal to 0.3 minus 0.3 A, right? So this will give me, if I solve this, 0.3, 0.4 A is equal to 0.2, and therefore A will be 0.2 upon 0.4, that will be 0.5 meter per second square. So I am able to find out acceleration, and I'm using one of this in, I don't want to move on to the next page, so I'll use this particular space to find out tension. T minus 0.1 is equal to 0.1 A, and therefore T is equal to 0.1 plus 0.1 A is equal to 0.1 plus 0.1 upon 2, right? So this will give me 3 upon 2 into 0.1, so this will be 3 upon 20, right? And that will give me approximately 15 upon 100, so 0.15 Newton. So tension would be 0.15 Newton. Okay, this is how we will handle this entire situation. Basically what we have done is we have got two equations, equation 1, right, and equation 2, and we solve these two equations for getting the values of T and A, right? Thank you.